All right, so next we're going to look at distributive property and combining like terms, okay? And this is how we're going to be simplifying algebraic expressions, right? So the distributive property, I'm sure you guys have probably seen both of these ideas before. Distributive property is really a combination of multiplying with addition, and it really comes from the idea that multiplying is a repeated addition. So let me just show you real quickly. I'll use an example like 2 times x plus 5. Now, with 2 times x plus 5, whenever you're multiplying, it's really a repeated addition. So if there's 2 x plus 5s, it's the same as having 2 of them added together, right? 2 times something is that thing plus itself. And so there's 2 of them there. And really, if we rearrange these things, we're looking at 2 x's and 2 5's, which is 2x plus 10, okay? Now, rather than going through and expanding like this, because if I didn't have a 2 there, if I had a 16, then I'd have 16 of these written out. I don't want to do that. So a simpler way to look at this is simply to multiply the 2 to each of the terms in the parentheses. It's equivalent to expanding it out. And so, but it's quicker. And so what we're going to do is multiply the 2 to both terms. 2 times x is 2x. And 2 times 5, 2 5's is 10. Okay? And so it's really equivalent to expanding it out. Okay? So 2x plus 10 is the simplified form. Now, we cannot combine like terms here. There are no like terms. Remember, like terms are going to be terms with the same variable part. The first term here has an x, the second term does not, and so they do not combine. Another quick example might be something like negative 5x times 3x minus y. Okay. Again, I can use the distributive property. When we're multiplying, we can distribute everything that's being multiplied on the outside to each term on the inside. So we take this entire negative 5x, multiply it by 3x. Negative 5 times 3 is negative 15. And the product of the x and the x makes an x squared. Okay, 2x is multiplied. Then we take the negative 5x and multiply it by the negative y, and the subtraction sticks with the y. The double negative makes for a positive. And then we have a 5xy. Okay, the x and the y, we just multiply them together. And it becomes a product of two variables, x times y. Okay, so negative 15x squared plus 5xy. And finally, we can put all this together and combine like terms using another example. Let's do something like this. Okay, so here I do all my distributing. So it's sort of, we also have to do an order of operations here too. There's a combination of a lot of things. First of all, I've got parentheses, but I can't do anything in the parentheses because they're unlike terms. I cannot simplify inside. So I look at the distributive property as an option. And the distributive property allows me here to multiply the 4 to both terms in the parentheses. So 4 times x is 4x. 4 times negative 8 is negative 32. And then likewise, I can distribute the minus 3. And I want to include the negative with that 3 because I'm really subtracting the whole expression. So that negative applies to everything. Okay, so I'm going to multiply that in. Negative 3 times 5x is negative 15x, or subtracting 15x. The negative 3 times 7 will be a negative 21, same as subtracting 21. Now I can combine like terms in this example because I have two terms that just have an x on them, and I have two terms that are just constant, they don't have a variable. So 4x minus 15x, I'm going to use the sign that is to the left of the term. So if I start with 4x's and I take 15 away, I'm going to be in the negative, because there's more negative than positive. It's going to be negative 11x. Okay. And then if I have a negative 32 here, and I take 21 away, you're going more negative, you end up having to add the two numbers together and using the negative, right? So the sign from the larger number, because they're both negative, you add them together. So 32 and 21 should make 53. Okay. So final answer, negative 11x minus 53. And we cannot combine those terms because, again, they are unlike terms. They have different variable parts to them.